Welcome. In this video we will see Metrosil sizing calculation. Next. What is Metrosil? Metrosil is the brand name for silicon carbide-based nonlinear resistors manufactured by M&I Materials Limited. Who is M&I Materials Limited? M&I Materials Limited is a strong global business that specializes in commercializing materials for demanding applications. Please see www.mmaterials.com. Next. Why Metrosil is required? One of the major operational hazards that may be encountered whilst operating a current transformer involves the secondary circuit being left in an open circuit condition, with the primary still energized. Open circuit conditions can occur inadvertently through routine maintenance of the burden or damage to the leads of the secondary circuit. High voltage transients may be generated in these situations and damage the CT winding insulation, possibly rendering it inoperable. In addition, these transients can cause high eddy currents in the CT core. These may be detrimental to the magnetizing characteristics of the CT and result in errors in the measurement accuracy. A Metrosil current transformer protection unit, CTPU, provides protection against potential CT operational hazards. It is designed to permanently connect across the terminals of the CT and operate without the need for user intervention. Next. Let's see construction and operation of a Metrosil CTPU. Figure shows the construction and dimensions of a single-pole Metrosil CTPU. A varistor disc is connected in parallel with a thermostatic switch mounted on a heat sink plate. Under normal working or fault conditions, with the burden connected, the varistor is subjected to an applied voltage. It acts as a passive load and draws little current, thus preventing inaccuracies in the measurement of the CT. During open circuit conditions, the varistor is exposed to an applied current and acts as an active load, limiting the voltage across the CT terminals and preventing any damage. The thermostatic switch manages the thermal cycling within the Metrosil CTPU when the CT is in an open circuit condition. A second thermostatic switch can be mounted on the heatsink plate for remote monitoring. Next. Here you can see connection of the Metrosil CTPU. Figure illustrates how a Metrosil CTPU should be connected across the secondary winding of a CT in parallel with the burden. It is advisable to locate the Metrosil CTPU as close to the CT as possible to prevent it being inadvertently detached during maintenance. Next. Protection of CTs and relays. Metrosil CTPUs protect CTs from damage under open circuit conditions. They do not protect relay or CT systems from overvoltages created due to high secondary fault currents. A Metrosil CTPU can be constructed in both single and three-pole varieties for convenience of installation. The procedure for choosing the correct Metrosil CTPU is shown over leaf. Next. How to choose the correct Metrosil CTPU? There are 6 standard Metrosil CTPU types that can accommodate a wide range of burdens and operating conditions. These are referenced by either a letter or a number. For simplicity, the procedure for selecting the correct Metrosil CTPU has been broken down into the following 5 steps. Step 1. Identify the relevant table for the application. Step 2. Select the Metrosil CTPU type. Step 3. Check the leakage current through the Metrosil CTPU with the burden connected. Step 4. Check the peak voltage which the CTPU limits the open circuited system to. Step 5. Confirm if a second thermostatic switch is required. Next. As per Step 1, identify the relevant table for the application. For metering applications, refer to Table 1. For protection applications, refer to Table 2. Next. As per Step 2, select the Metrosil CTPU type. For metering applications, using Table 1, Select the Metrosil CTPU according to the CT-rated secondary current and the CT burden of the system. For protection applications, using Table 2, select the Metrosil CTPU according to the CT-rated secondary current, the maximum fault current as a multiple of rated current, and the CT burden of the system. Next. As per Step 3, check the leakage current through the Metrosil CTPU with the burden connected. Using Table 3, refer to the Metrosil CTPU derived from Steps 1 and 2 above. Identify the secondary voltage that appears across the CT under normal operation and cross-check that the leakage current will not affect the measurement accuracy. In addition, check that this current can flow for an infinite time. Next, refer to the secondary voltage that appears across the CT under fault conditions and cross-check that the higher level of leakage current will still not affect the measurement accuracy. In this case, the current must be able to flow for a period of time greater than the maximum fault duration. Table 3 is for selection purposes only and is not representative of the specification of the CTPU type. If the values and times are acceptable, proceed to Step 4. If they are outside of the requirements, please contact the Metrosil team. Next. As per Step 4, check the peak voltage which the CTPU limits the open-circuited system to. Use Table 4 to check that the chosen Metrosil CTPU will limit the voltage to a level that will not damage the CT. Next. As per Step 5, confirm if a second thermostatic switch is required. Specify whether a second thermostatic switch is required for remote monitoring or signaling purposes. Next. Now let's see practical example. We will consider for bus bar, bus section and bus coupler protection CT data. Class TPS. CT ratio 3000-2500-2000-1500/1 Amepere. Adapted CT ratio 3001 ampere. CT internal resistance 5.2 ohms. Knee point voltage 2500 volts. Magnetizing current 20 milliampere. CT internal burden 5.2 Wa. Metrosil connected tap 3001A. Our total, our lead plus relay burden, 1.098 ohms, as per CT sizing calculation. Next. Now let's calculate maximum steady fault current. Imax is equal to short circuit current CT ratio is equal to 42,600/3000 is equal to 14.0 ampere, RMS. Imax is equal to 20.08 A, peak. Let's suggest the use of the type CTPU 3134 with following details. Current transformer protection unit spec 3134 with additional thermostat. Manufacturer, Metrosil Ltd. The Metrosil calculation will verify the 3001A. Next. Step 1. Identify the relevant table for the application. Metrosil is used for protection applications, not metering, therefore we will refer Table 2. Next. Step 2. Select the Metrosil CTPU specification. Secondary current is equal to 1A. Maximum fault current is equal to 20 times. Maximum fault current at secondary side is equal to 42,600 by 3000 is equal to 14.2 ampere RMS value. The knee point voltage of CT is a 2500 volts TPS class at 3000 ratio. Hence, we selected CTPU 3134 as per CTPU selection guide table 3 and 4. Next. Step 3. Check the leakage current through the Metrosil CTPU with the burden connected. We propose to select in any case the maximum, means 3134. Step 4. Check the peak voltage which the CTPU limits the open-circuited system. Type 3134 means limit to 2856 volts peak, respectively 2000 volts RMS. Next. Step 5. Confirm if a second thermostatic switch is required. Yes, this is required for alarm purpose. Summary. Metrosil type CTPU 3134 fulfill all requirements. Metrosil type CTPU A, B, C 3166 or 3140 are not possible. The type 3134 CTPU is a standard offering for all current transformers with 1 ampere secondaries that do not have high impedance burdens. Next. Stay tuned, we will discuss other technical stuff in upcoming videos.